to get a hold of them. I don't know. Hey, Bonzupi, yo, I'm early. You're very early. Welcome on in. Good to see you, Bonzupi. Good to have you here. I'm kind of excited today because we have a really good path forward on our embedding model, and I want to implement it. I'm like really excited about it. I think it's going to be, I think it's going to work. I don't know how good it's going to be, but I think it's going to work. Yeah, how's it going there? Jidefo Lobby. Yes. Wait, hold on. Did you say yes? Yo, how's it going? Good to have you here. You can't see me, but I'm making a goofy flex pose. Yeah, I can't see what you're doing, but I can imagine it. I can imagine it up here in my brain. I can imagine it. So I think we're gonna want to use linear layers, even though, because we need to. So here, what does our output need to be? Our output needs to be, we want the embedding. We actually want the output embedding. But when we're training the model, in training mode, we don't want the embedding. We want to be able to derive some sort of relationship between the words that are being used and passed through in the system, right? I think so. So let me think that through. So we need to vectorize each of these, right? So these would be 1-hots. So each of these words is 1 hot. And then we have a max context size. Sadly, no, I think he went to sleep, so I just used the info I had once I have. Oh, all the specifics, I'll send them to your consultant. Oh, that sounds good to me. Hey, Loons, good to see you. Welcome on in. Happy Tuesday. We're going to be building ourselves here, our embedding model. And we need to figure out what the path is forward because I think, you know what? We've got some challenges ahead. We got some challenges ahead. Good to see you. Welcome on in. I think we're gonna do pretty good though because we'll do fine. Don't worry. So here's why I'm confident we'll do fine because we have a backup plan. We've got a backup plan right here. We know we can use something that already works, but we're gonna try to do this ourselves. We're gonna try to make it work as best as we can. All right. So let's see, where do we leave off? All right, so we've got number of words, we've got our embedding, and then we also need to, this is gonna be the output size. So the total embedding size, I believe, let's do a forward pass on this and see what happens. Because I think the output size is gonna be immediately 256. And what this is like the next word in the series. So if you're gonna train like an LLM style, like an LSTM or something like that, and have an LSTM layer, then we can predict long-term, short-term stuff. With just the embedding alone, we might be able to get away with just some linear layers. Like maybe 1 million? Not that many. It won't be very many. Don't worry. It's not that many. Maybe 1 million. Not a lot. So let's see. I need to do a forward pass on this really quick so I can see what's going on. And I only want the embedding output. And so that's going to give me basically a bunch of random numbers. However, I want to see if the random numbers are specifically a full set of 256, and they should be because it's a 1-hot on the input though it's a 1-hot for every word, right? So is it going to give me back the full? Oh, it is. So it's going to give me back. Are we going to batch the words? Let's find out. We're going to find out. Very small. Hey, Steven, 1-hot. Yep, Zergio, 1-hot. You got it. That's what we're going to do. We get the 1-hot. The 1-hot's automatically taken care of. Technically, it's not a full one. Basically, it's index-based 1-hot. So it's going to multiply, find the row that's associated with it, and return the row. No need for a mat. Let's do I want to do full forward pass to see. So we needed to vectorize first. So I think we did that. Let me check. Where we're at. So we did our vectorize. Let me see. Let's run it really quick. Here we go. All right. So, we have a bug. We have a bug right here. We do want to fix that. We do have to fix that because otherwise it's going to be a problem because we can't normalize it otherwise. So we need to fix this bug right here. This bug has, you can see it's in multiple places. So right here, you can see there's a period. There's a period here. There's a period here. However, that should have been solved. That should have been solved with this little pretty regex right here. It should have been right here. And I even have the R right in front of it. So why isn't it doing a replace? Is it doing a replace on one or all? How about we just get rid of the plus? Is that gonna fix it? Yes, it did. Oh, no, it's still there. It's still a problem. Why is it not working? Here, I'll tell you what. No, I needed everything that's not an alphanumeric character. That seems perfectly straightforward to me. And not a space, because I need this space, because it's syntax for us. It's syntax. So why is that replace not working? Do you guys see what the problem is? I wonder if you guys see it. I don't. A to Z, we don't really need that. 0 to 9, which is a number. Got some numbers in there. Let's write a custom embed class instead of using torch.nn.Embedding. Oh, we could do that pretty easily. I could do that. All right, Dina, we could do that. That's not a problem. It's actually a really easy thing to do. And all right, let's do it. All right, you guys, we're gonna do it. We're gonna do it. Okay, Dina, thank you at Dina. We will write our own to do this. So we're going to do it. We will. So it's going to be self.embedding equals, we need to do a tensor. It has to be a tensor. We could do it differently. Torch.tensor, and it should be the dimensions of this. And then we need to say bias equals false. I think that'll do the trick. And then the only thing is though, when we do the back pass though, we need to, I don't know how that's gonna work. Well, technically, the forward pass we have to change here is what we really gotta do. Because it's not just a straightforward, because it's not gonna be a matmul. So we have to do a little bit of extra stuff here. I think this is what we have to do. How's it going there, Ronnie? Good to see you. What's up, Steven? Starting without you, we're just a little bit. Don't worry, not by only a few minutes. We're good. You got here on. That won't work because we have to vectorize it with our vectors there. Double check the vector. Yep, vectors. Okay. Vector. I'm just gonna say vectors. Let's update. Let's up. Thank you for the hearts, you guys. Appreciate it. Good to have you here. Happy Tuesday. All right, that should definitely work. What? Argument dictionary not found. What do you mean? What? Hold the phone. What's going on here? Oh, right. Okay. How do we deal with that? We've got a problem. All right. So can we set the dictionary? Here we go. Embedding dictionary. We're just gonna set that here. We're gonna put the dictionary inside, you guys. Dictionary inside of it. It's gonna be inside. I need it to be a dictionary. There we go. Finally, it answered. It did. Oh, it took a little while. I have done it in TensorFlow. You basically need to define a train step. Yes, function in the subclass. Don't know how it goes in Pytorch. Ronnie, we're gonna give our best shot. We're gonna give the best shot we got. I think it's gonna work. I'm pretty confident we'll figure it out. I haven't done this before, but I think we'll figure it out. All right, so we're gonna store a dictionary. Put a dictionary here, all good. And then we need to pass in the self dictionary. No, I need this word, thank you. Dictionary, okay. So that should allow us to pass it. We already got our vectors here, but that's just for testing. We actually need to pass in the words directly. So this will be a sentence, perfect. Now we should get tensor object is not callable. Where's that at? Who's doing that? Oh, okay, right. So this is a tensor object. Remember, autograph will auto pick it up in the backward. Dina, oh, I really hope so. That would be really great. That's the whole point of autograd. Autograd is supposed to take care of that for us. Dina, all right, you made me really happy right now. Because I was like, oh, we're gonna have to create another module, aren't we? Which it probably wouldn't be bad. It's just that we'd have to define the backward pass or the creating of the gradients, which isn't that big of a deal. We could do it. It's just I didn't want to. Although if we have to, we will. Because Dina, you got it right here. This is your idea right here, and we're gonna make it work. Let me see what this looks like first here. And apparently, I don't do anything. Argument indices position 2 must be a tensor, not a list. Oh, right, okay. So when we vectorize, let's turn this into a tensor. Torch.tensor. And then comma d type equals, and it needs to be torch.long. think torch is not long, right? What is the long version of torch? Python. What is it called? So import torch. What's up, everyone? JM, good to see you. Good to have you here. Happy Tuesday. What do you mean? Yesterday he said the opposite. It shouldn't continue our embedding, word embedding. All right, let's close this out here. Then we're going to rerun that. Hey, there we go. That's what we're looking for. And we got back some very interesting results that I was not quite entirely expecting. Although it is, so we do, each word gives us back an array, right? So what is the size of that? What is the size of this on this response? So out equals, let's grab this here. And then we're gonna print out, and we also want to print the shape. Let's try that, see what we've got. Okay, so how many words are there? So I think now that I've got the numbers that I'm looking for, the output, now I can validate this embedding here, which requires me to change this forward pass just a smidge. We have to change this here. So we have to do our own one hot, and then we have to do a matmul. We don't have to do matmul. We can just do an index. Do we have, no, wait, we don't even have to do one hot. We just do an index. Watch this. Can we do that? Can we do that? Will that work? I'm actually kind of curious. This actually might work. Let's see. Oh, it might. Tensor's got pretty magical capabilities. Hey, look at that. Hey. All right, there we go, Dina. I think we just did the trick. We just index backward. It did right there. Index backward. Look. I think we did it, you guys. Yep, right there. It says embedding backward, but this is index backward, which should do the trick. It should. I think it should. So there you go. We got ourselves number word, dictionary, and our very own embedding. It's legit embedding. It's legit embedding. Check that out, you guys. Isn't that great? Okay. So now that we've done this, we've done our vectorization, we've done our tokenization, we did our normalization, right? Here we do, this is the tokenizer, build the tokenizer. And then inside of our vector, we will use the dictionary to generate our tokens. So this is really our tokenizer. It's not vectorized. Let's call it a tokenizer. Tokenizer. There we go. All right, so we did this. Let's just mark a green check mark here. We don't really have a data set, but we're gonna use the one that we have right now. I believe our forward pass is working. Is it working completely though? We need to do a data iterator. All right, let's add that on our to-do list. All right, so we need a data iterator with a yield for batching. So we're gonna do our own batching, because I don't want to use the built-in one. I want to build my own. The data loader and the data model is just, it feels like it's extra work. And it just feels extra. It just feels extra. So we're going to create a tensor with random long with the size length of the input training data. So then we can batch shuffle. The only thing is, when we have a bunch of words, so this is why we need to build our own. We won't be able to use a data, well, I suppose we could. We just have to create an n-gram pattern for the data loader. We're gonna say, here's 3 words, and then the next word will be this word, right? So you've got 3 words at the input, and the output will be the 4th word. And so we'll create that array. We'll create that data set using our words. So you can see here on the screen. That's the plan right here. 3 words in 1 word. We're making the AI. Well, we're building the embedding layer. So it's sort of like the front part of the large language model. Because when you throw words into, right, say you got a bunch of words here. Actually, I've got a diagram right here. So you got a bunch of words right here, like the dog ran up the hill. We need to tokenize that by converting them into an index based in a dictionary. Like what number position are they in a dictionary? We'll turn them into a number. And then any remaining context that's unfilled, we pad it with zeros. After that, we convert that into a one hot, which just makes it, basically turns it into a bunch of an index directly. So, for example, this is 5. 1, 2, 3, 4, 5. This is equal to 5. 5 equals this. So you can see what the 5 is there. And then we do essentially a matmul on that. That will give us one row from the embedding linear layer. And each row looks like this. So that way every word comes out as a... what are you going to train the embedding with? So it's going to be simple data. We already have the training data. It's not that complex. So it's going to train it on the next word. So here, check this out. All right, Sergio, ready? So we're going to give it 3 words here. Actually, let's highlight this. So these 3 words, found the bug. And then we're going to say the output is going to be the next word there, which is going to be win. Found the bug, win. And then we're going to train it on the next 3 words. So it'll be these 3 words here, right? So the bug, win. And then the training word is going to be you. Right there, you. So we're going to... Why the? Why the? Why the what? Why the what? Because we need to train it on knowing what the features are going to be on the input, so that way it knows what it's going to understand at the next word. And what that should do is it should train in a way to identify meaning in the words. It should find relative position meaning. Training now. We're a little bit away from training. We're actually not too far off from training. We're getting close. We're getting close, Sergio. We got our tokenizer. We built the dictionary. We've got a normalizer, and now we got our cross entropy loss, which is going to work with a 1 hot because negative log likelihood loss fails with 1 hot, and we need a 1 hot in order to train a model because we need to have a target output. So I need to vectorize this 4th word right here. The 4th word win, and we're doing that right here. So let's do that really quick. So should I have a tensor here? I think so. I think we could do this in a batch, maybe? Do we want to do this in a batch? We don't have to do this in batch here. We could do that separately. Let's not bother. Let's not try to over-optimize right now. You lost 2 days trying to set up a local model with LM Studio and Quinn 3.6. It was real disappointment. Oh no! Here, so, hey Cathix, thank you for saying hi. Let's get back to our model real quick. Also, just some background in large language model research help in the interviews. Yes, I think so. Have you built your own filters, your QKV filters? Yes, from Paris. Hey, you're from France. You're over there in Paris, France. Nice. Did this work? It did. It was number 4. Okay, so that's what we were looking for. All right, that looks good. So now we need to return. Oh, right, because it was a pass, so it's definitely going to return nothing. So, zeros, and the zeros need to be the shape for, it needs to be the size of the dictionary. So we need to do length of dictionary. Okay, so this will be len dictionary. And then we need to scatter the tensor. See, is that gonna work? Tensor, let's see you there. Hey, Speedy Gamer 9K! Thank you for subscribing. Welcome on in. Good to have you here. You joined the right channel for software engineering. That's what we're doing here. We're building ourselves a embedding model with Pytorch. Yeah, so it's not fully from scratch. So it's going to give you the ones that you were going to scatter over. Got it. But then what's source? Why do you need source? Oh, 1. Okay. So this is a 1. And this is the index. Let's try it. All right. Zeros dot scatter underscore. And then it was the target. We got the target. It's gonna be 0 because of the zero position. And then the index is going to be the tensor. right? It's a tensor right there. It's a tensor. And then 1, like that. Let's try that. See if that works. Oh, that works. We did it. All right. There you go. So that means that we can put this all in one line now. And just say return. See if that works. Let's see if that works. All right. There we go. We figured it. So that'll be our label. That'll be our label. We're going to see if that works. That'll be our label. All right. Now we need to make a data iterator. Let's grab, should we do a sentence or a vector? I think we could do the sentence. Let's do the raw sentence and we'll vectorize it. So we already have our dictionary. Sentence, dictionary, vectors. So we could do this. So we got our features. And then when we throw the words in, this is the source. Or the model just wants the word. The output, though, needs to be the actual one hot. So we need to iterate over the words here. It's gonna crash right there, but it got part of the way there. So let's see here. And it's not supposed to be a tensor. It's supposed to be the actual. No, it is. It is. And I want that to be a one hot. So we should one hot that. All right, labels. Labels are going to be feature label. Let's do a one hot on this. There we go. That should do the trick right there. The only thing is, our input tensor goes to 0 quickly. Oh, right, okay. Index +3. There we go. Now that should do the trick. Perfect. That's what we're looking for. That's it, exactly. So what we need to do now is we get an index out of range. We need to exit the loop before that. And that's what this if statement is here for here. All right, so we got our training data. Looks like it's good to me. We got our one hot. So now we can train the model because we got all of our inputs. So we should be able to easily, so we got our features and labels. We should be able to do out equals model features and then print out. See what we get. Let's hide all this other stuff. We don't need any of these things now. We need the words. Okay, let's try it. Number of words. Oh, did oh, right. We still need to build the dictionary. There we go. Vectors. We don't need the vectors anymore. I'm pretty sure we don't use them. Yeah, okay. Looks good to me. Excellent, excellent. But you want to. Hey, might as well. I want to too. For simple auto diff, the syntax is off-putting. With auto diff, here's what we're gonna do tomorrow. So we're going to do train the model here. We'll start the training process and we will have to mess around with how we're dealing with all the different layers in order to get a good outcome, because we want to be able to test similarity. So we have a lot of to-do items here. Let's commit this code here. Get status. Get, oh wait, rm quote mark. No, rm quote mark backslash. Get add status. Commit am. We fixed our iterator party popper. There we go. Push main. Oop, no. Get push origin main. There we go. Perfect.